by proper. So k is my real number. Therefore, by trichotomy property of real numbers, so k can be 0, k can be positive, k can be negative. You know that by trichotomy property of real numbers, so k can be 0, k can be positive, k can be less than 0. If k is 0, what is my d plus k? My d plus k is itself d. You know that d is a metric. So therefore, in this case, d plus k is a metric. Understand? D plus k is same as saying that d, because d plus k is nothing but d plus 0. D plus 0 is nothing but d. You know that d is a metric. Therefore, d plus k is a metric. Again, let us start with k positive. What about k positive? Whenever k positive, does it mean that d plus k metric on x? Understand? If k is positive, what about d plus k? What about d plus k? Is it a metric? Is it a metric? So the answer is suppose, see, for sake of our convenience, you know that cardinal of x should be bigger than 1. Already I told you. So therefore, I start with two elements. In fact, I start with one element, d of x comma x plus k. So what is this actually? So loss of generality, I can assume that this is nothing but actually what? Suppose d of x comma y is d of x comma y plus k. This is my delta of x comma y is nothing but d of x comma y plus k. Question is that is delta is a metric? So what is my this? So delta of x comma x is equals to d of x comma x plus k. But what is d of x comma x? You know that whenever d is a metric, d of x comma x is 0. Therefore, this 0 plus k, that is nothing but k. Therefore, this is positive, not equals to 0. Therefore, delta of x comma x is non-zero. But here x and x are both are same. X and y are same. Understand? So delta of x comma x, that means distance between x comma x is non-zero, but the points are coincident. Therefore, delta is not a metric on same set x. Whenever k is positive. Whenever k is positive. Is it clear? Is it clear, Amma?
Yes.
Yeah. So what about the k negative? What about the k negative? If you take k is negative, what is my metric actually? So suppose delta of x comma y is equals to d of x comma y plus k. So for k negative, is it a metric? Is it a metric? Is it a metric?
No.
No, sir. It is odd.
So what is a counter? What is a counter? Suppose you take understand. Suppose you take delta of x comma x, same strategy. What you get actually here? D of x comma x plus k. That is nothing but what? D of x comma x is 0. 0 plus k. That is nothing but k. You know that k is negative. K is negative. Therefore, delta of x comma x is non-zero. Delta of x comma x is non-zero, but the points are coincident. The coordinates are coincident. That means the coordinates of the point are coincident. Therefore, delta is not metric. Delta is not metric on a set x whenever k negative. So what you conclude? What you conclude? This d plus k, this d plus k is a metric. So is a metric if k equals to 0. K equals to 0. So d plus k is not a metric. Not a metric if k positive and as well as k negative. Is it clear? Okay. So let us start with second example. Suppose D is my metric. D is a metric on my set x. Okay. I can take another distance. The distance is defined by like this. Mod of x minus y divided by, for sake of our convenience, I'm going to take usual metric. I don't want to consider this one. Okay. Is it a metric on R? Is it a metric on R?
Metric, sir.
So there is no problem with first condition. You know that there is no problem for the first condition because actually not. Mod of numerator is non-negative and denominator is positive. You know, 1 plus mod of x minus y, which is always bigger than or equals to 1 plus 0. That is nothing but 1. 1 is positive. Therefore, denominator is positive and numerator is non-negative. Therefore, total is non-negative. So therefore, there is no problem with first condition. There is no problem with first condition, right? So what about the second condition? If x equals to y, that means what? Delta of x comma x, that is nothing but what? D of x comma x divided by 1 plus d of x comma x. What is d? So that means mod of x minus x divided by mod of x minus x, that is nothing but what? 0 by 1 plus 0, that is nothing but 0. Therefore, if x equals to y, we have done it, right? If distance is 0, that means what? That means what? Mod of x minus y divided by 1 plus mod of x minus y equals to 0. You know that denominator is never 0. We have seen this denominator is never 0. That means what? Numerator must be 0. That means what? X minus y equals to 0. That means what? X equals to y. So both waves we have done. That means distance is 0. Distance between 2 points is 0 if and only if x equals to y. So therefore, there is no problem. Yeah, tell me. Any doubt?
No, sir. Carry on.
So therefore, third one, symmetric, right? You start with two elements. Again, I already told you that there is a modulus, so there is no problem. This can be rewritten as y minus x divided by mod of 1 minus x. This is nothing but what? Delta of y comma x. Therefore, symmetric property also true. What is triangle inequality? Is it true actually delta of x comma y less than or equals to delta of x comma z plus delta of z comma y? So we can do this problem, we can solve this triangle inequality in two to three ways. So one way is basically what I do is basically, you know, actually I want to show this. So what I do is right. So you know that actually is it an increasing function? The answer is because it is a differentiable function because on this domain it is increasing function. Why? Because whose derivative is what? Derivative is nothing but 1 plus x into 1 divided into x into 1 divided by 1 plus x whole square. Therefore what? 1 by 1 plus x whole square. Therefore it is always positive. Therefore derivative positive means what? It is an increasing function. It is a increasing function. So therefore f is increasing function. F is increasing function on which interval? 0 to infinity. But you know that actually we know this triangle inequality. What is the triangle inequality? You know this inequality. You know that the mod of x minus y is nothing but what? Mod of x minus y is nothing but 1. So this can be rewritten as x minus z plus z minus y. This is nothing but what? Mod of x minus z plus mod of z minus y. Right? You know this is non-negative. You know this is non-negative. You know this is non-negative. Therefore, these are in the elements in the domain. These are mod of x minus y are the elements in the domain. This also element in the domain. This is also element in the domain. Therefore, whenever it is in the element in the domain, and you know that increasing function definition, whenever x is less than y, f of x is less than f of y. You know, f is my increasing function. Therefore, f of mod of x minus y less than or equals to f of mod of x minus z plus mod of z minus y. Is it clear? Because this is my x, this is my y. You know, x is less than or equals to y. That will imply that f of x less than or equals to f of y by increasing property of increasing function of the function f. Is it clear? This is important step. So put it in chat box. Is it clear, all of you?
Yes, sir.
Okay. So therefore, this is nothing but what actually? What is my f of x? My f of x is nothing but x by 1 plus. So is there any doubt? Yeah, yes, okay. So therefore, what is my f of x? X by 1 plus x. Therefore, what is my x? X by 1 plus x. Therefore, this is nothing but this is less than or equals to x by, this is my x by 1 plus x. Right? But what is this one left side? Your distance function. Your distance function. So you can split this function into two fractions. Right? So therefore, this is a denominator is very big. So I need to take like this. This is always less than or equals to mod of x minus z. This is denominator is very small. This denominator is very big. Therefore, this is always less than or equals to this. Similarly, this is always less than or equals to this. But what is this? Distance between x comma z plus distance between z comma y. Therefore, D satisfy all properties. Therefore, D is a metric. Therefore, D is a metric.
Sir, can you explain again? I did not understand.
Triangle inequality or something else?
From delta of x, y. After f of x minus y, sir.
Last step, madam. Triangle inequality. Did you what you
Yes.
understand?
Yes, sir. Last
okay.
condition.
Okay, Amma. So therefore, what I do, so there are several methods to solve this. Actually, triangle inequality, I already told you. So this is one of the arguments. So to show triangle inequality, one can define, one can use the function which is always increasing function. So therefore, I define a function f of x is equals to x by 1 plus x. So you know that this is always increasing function because whose derivative is positive. Once the derivative is positive, always f is increasing function. Is it clear? Is it clear?
Yes, sir. Yes.
So what is your domain? Domain is non-negative real numbers. So therefore, yesterday I told you this mod of x minus y less than or equals to mod of x minus z, mod of z minus y. This is non-negative, this is non-negative. So here this is my alpha, this is my beta, right? So alpha less than or equals to beta, we know that. So that means what? F of alpha less than or equals to f of beta. This is my alpha, this is my beta. Therefore, f of alpha less than or equals to f of beta. So what is my f of alpha? Alpha by 1 plus alpha. What is my f of beta? Beta by 1 plus beta. Is it clear?
Yes, sir.
So therefore, here denominator is very big. So once the denominator is very big, the fraction is very small. So therefore, I restrict the domain. I restrict the denominator. So therefore, I'm considering only 1 plus mod of x minus z instead of taking total denominator. So this is always less than or equals to this. Similarly, in the denominator of this is very big. Therefore, this fraction would be very small. Therefore, I can control this denominator. So therefore, instead of taking total denominator, I'm taking only 1 plus mod of z minus y. But what is this? Delta of x comma z. What is this? Delta of z comma y. Is it clear, Amma?
Okay, sir. In the previous step, modulus of x minus z by, I think.
Modulus of?
Last before.
Yes,
Yeah.
madam. Yes, madam. Okay, small, right? X minus z.
X minus z. X minus z.
Numerator also x minus z. No.
Yeah,
The
this is x
previous
minus.
step, sir.
Okay.
Last but one step.
Okay, madam.
This is x minus z. This is x minus z. This is x minus z. Okay.
Okay, sir. Clear.
Okay. So this is a metric. Okay. Delta is a metric. Suppose, is it a metric? The answer is same argument. Same argument. So what I do? See, there is no problem with non-negative. Non-negative is always clear, and symmetric also clear. One is non-negative clear, but same argument. So and second property also hold, means d of x comma y is 0 if and only if x equals to y. So there is no problem with the symmetric property, right? Again, instead of proving that that actually this is 2 is there, what I do is that I need to define an increasing function like this, x by 2 plus x whenever x is non-negative. So this is clearly increasing function because whose derivative is positive, right? 2 plus x into derivative of this is nothing but 1 divided by 2 plus x whole square. Therefore what? 2 by 2 plus x whole square, this is positive. Therefore it is an increasing function, therefore same steps. Understand? Is it clear?
Yes, sir.
Okay. Suppose, therefore D is a metric. Suppose d of x comma y is equals to mod of x minus y divided by minus 2 plus mod of x minus y. Is it a metric or not? Put it in chat box. Is it a metric or not? Good, very good, very good. Right? So what is my that actually the problem with actually non-negative, because there is a minus sign here, therefore we need to expect something minus is there, therefore we need to expect that first condition would fail. Suppose I take x equals to 2, y equals to 1. What happens? Therefore distance between x comma y is equals to 2 minus 1 divided by minus 2 plus 2 minus 1. Therefore 1 by minus 2 plus 1. That means what? Minus 1 minus 1. Therefore it is less than 0. Therefore distance, already I told you, distance cannot be negative. Therefore it's not a metric. Is it clear? Is it clear?
Yes, sir.
Suppose you take this. Suppose you take this. So suppose distance between x comma y is equals to mod of x minus y 2 minus mod of x minus y. Is it a metric or not? Is it a metric or not? Is it a metric or not? No, very good, very good. So therefore, suppose I can take x equals to 2,
10, 5.
y equals to 0. What happens? So therefore 2 minus 0 divided by, what is this? 2 minus 0. That means what? 2 by 0, this is infinity. Already I told you, distance between any two real numbers should be non-negative. This is my first property. Distance must be non-negative real number. So therefore here distance is infinity, therefore it is not a metric. Right? So what is the problem you are facing? So there is a problem in the denominator should not be negative, right? So therefore, what is the problem? Therefore, distance between x comma y is equals to mod of x minus y by k plus mod of x minus y is always a metric if and only if k is positive. Whenever x comma y is a real number. Is it clear? So what I do for the triangle inequality, I can take an increasing function like this. X by k plus x. X by k plus x. Therefore, it's an increasing function. One can prove that D satisfies the triangle inequality. Therefore, D is a metric because all the remaining properties are trivial. All the remaining properties are trivial. The only thing is that you need to inquire the triangle inequality. Triangle inequality is obvious by taking the function to be x by k plus x. This is an increasing function. Therefore, it is always a metric. Is it clear? So therefore, one can generalize this concept to any general metric. That means, suppose D is a metric on X, one can generalize it. So D is a metric on X. So suppose I can take D of x comma y is equals to D of x comma y divided by 1 plus D of x comma y. This is also a metric on X. The same strategy, right? K plus, where K is positive. Is it clear? Is it clear this step? This is a metric. This is also a metric. Whenever D is a metric on X, whenever K is positive, this function delta of x comma y is also a metric on X. Same set X. Is it clear? Say yes or no? Most of the books follow this notation, right? Is it clear? Put it in chat box. Yeah, yes, okay. So therefore, this is always a metric. Okay. I hope you understand. Right? So next is, So next example number 8. Suppose if you take x equals to r, my distance function is minimum of, suppose, k d of x comma y, where k is a real number, right? Whenever x comma y belongs to r. Question is that, is it a metric? So what is the possibility you need to check? You need to check for 3 conditions. Either k can be 0, k can be positive, k can be less than 0, right? There are 3 problems. So suppose if k equals to 0, what is my distance function? So this is my delta. You need to use this notation, delta. Or else you need to take this reverse, mod of x minus y. This is the d of x comma, right? Mod of x minus y, k comma mod of x minus y. Okay. The thing is that, is it a metric? So what is d of x comma y? D of x comma y is equals to, whenever k equals to 0, this is k0 mod of x minus y. So what is the minimum? Minimum is 0. You know that. Why the minimum is 0? Because mod of x minus y is always non-negative. So therefore, what is the lower bound? 0. Therefore, what is the minimum? 0. So therefore, distance is 0. This is true for any 2 real numbers. Therefore, what is the distance? Distance is a constant function, 0. Therefore, already told you, it is not a metric. So D is not a metric whenever k is 0. Is it clear, Amma? Is it clear, Amma?
Yes, sir.
Yes, sir.
Okay. So therefore, what is my second case? Whenever k positive, what happens? Suppose I want to counter k negative first of all. What is the k negative? So what is my distance function? You know, distance function is nothing but minimum of k comma mod of x minus y. So what is this actually? You know, actually k mod of x minus y is always less than k, because k is negative, mod of x minus y is non-negative. This is negative, this is positive. Therefore, k is always less than mod of x minus y. So what is the lower bound? K. Therefore, what is the minimum? K. This is true for every x comma y belongs to R. You know that actually it is a constant function. In fact, it is negative. Is it a metric? No.
No.
Is it a metric? No. Yesterday I told you that it cannot be constant function. So therefore, in fact, it is negative. Therefore, it is not a metric. So whenever k is negative, it is not a metric. So what is the remaining case? K positive. K positive. So that means this is minimum of k comma mod of x minus 1, right? So to counter this argument, actually, for convenience, for understanding the problem very trivially, I'm going to take k equals to 1. Then I can extend this idea to k, any positive real number. So what is my d of x comma y is nothing but 1 comma mod of x minus y. Once you prove the result for k equals to 1, automatically the result is true for k positive. I can prove it. So what is d of x comma y? Minimum of 1 comma mod of x minus y. Is it a metric? The problem is, you know that it is non-negative. There is no problem. It is positive. So non-negative, positive, this is always non-negative. Therefore, first condition hold. What is my second condition? If x comma y equals to y, if x equals to y, what is d of x comma y? D of x comma y is nothing but a minimum of 1 comma mod of x minus x. Therefore, minimum of 1 comma 0. Therefore, what is minimum of 1 comma 0? 0. Therefore, whenever x equals to 0 is always 0. So therefore, what is the converse? If d of x comma y is 0, that means minimum of 1 comma mod of x comma y is 0. So either minimum can be 1 or mod of x minus y by order axioms, by trichotomy property. So therefore, either minimum can be 1 or mod of x minus y. Whenever 1 is less than mod of x minus y, the minimum is 1. Whenever 1 is bigger than mod of x minus y, the minimum is mod of x minus y. Therefore, there are 2 possibilities. If you take minimum of these is 1, is 1 equals to 0? No. So therefore, there is no possibility the minimum to be 1. The minimum to be 1. So what is the possibility? Mod of x minus y equals to 0. So therefore, x equals to y. Is it clear, Amma? Is it clear the step? Minimum either 1 or mod of x minus y. There is no chance to 1, because if it is 1, minimum is 1. So 1 equals to 0. Is it true? So wrong. Therefore, what is the chance for this? So mod of x minus y. Therefore, mod of x minus y equals to 0. That means x equals to y. So we have done that both cases. Right? Distance is 0 if and only if the points are coincident. So there is no problem with the symmetry property. This is nothing but what? Minimum of 1 comma mod of x minus y. But I already told you that 1 is nothing but 1 comma mod of y minus x. This is nothing but what? Distance between y comma x. Therefore, distance satisfy triangle symmetry property. So what about the triangle inequality? What about the triangle inequality? Triangle inequality, in order to prove the triangle inequality, first you need to observe two things. What is my distance? Distance function is a minimum function. 1 comma d of x comma y. Right? 1 comma d of x comma y. Sorry, d of mod of x minus y.
That's nonsense.
Right? D of mod of x minus y. Okay. The thing is that there are two possibilities. Minimum should be less than or equals to 1. Minimum should be less than or equals to mod of x minus y. Is it true? Did you accept this step? Minimum of 1 comma mod of x minus y is always less than or equals to 1 and mod of less than or equals to mod of x minus y. Did you accept this step? Because minimum is always lower bound for the set, na? Minimum is always lower bound for the set. So therefore, this is always less than or equals to each member in the set. Each member in the set. What are the members in set? 1 and mod of x minus y. Therefore, minimum is a lower bound for the set. Therefore, minimum of this is always less than or equals to each member. So therefore, this is less than or equals to 1 as well as mod of x minus y. Is it clear, Amma?
Yes, sir.
Okay. So therefore, I want to show the triangle inequality. So what is our aim? Our aim is to show the triangle inequality. So distance, I want to show the distance between x comma y less than or equals to distance between x comma z plus distance between z comma y. I want to show this. Right? So I need to take three elements. Right? So suppose your distance function d of x comma y. See, what is the possibility? Distance function less than or equals to 1. That means what? Distance function can be 1 or less than 1. It cannot be bigger than 1. It cannot be bigger than 1. Therefore, distance must either distance between x and y can be 1, distance between x and y less than 1. So it cannot be bigger than 1. So there are two possibilities. So distance either 1 or less than 1. So I'm taking first case. If either of them, distance is 1, distance between x comma z is 1, or distance between z comma y is 1. If you take this case, is the inequality true? If you take this case, distance between x comma z is 1 or distance between x comma z is 1. What happens? If distance between x comma z is 1 means what? It is 1. Left side is what? Actually, left side is less than or equals to 1 because distance between x comma y is always less than or equals to 1. Left side part is less than or equals to 1. If the distance is equals to 1, what happens? So 1 plus some non-negative constant. So always this inequality holds. Is it clear? Always this inequality holds. Because right side is 1 plus non-negative constant, left side is at most 1. Left side is at most 1, right side is at least 1. Understand? This is at most 1. What is the right side? Sum. What is the sum? At least 1. So which is bigger? Right side is bigger. Therefore, in this case, the triangle inequality holds. Is it clear the step?
Yes, sir.
Right? At least left side, at most right side. At most left side, at least right side. So therefore, triangle inequality holds in at least one of the right side is 1. So therefore, what is the negative of this part? Distance can be 1 or less than 1. So what is the negative of this? Distance is less than 1 and distance between z comma y is less than 1. Right? So distance between x comma y means nothing but what? Actually minimum of 1 comma mod of x minus z. So what is the chances? 1 or mod of x minus z? Is 1? Is minimum of 1 comma x, mod of x minus z is 1? No, because if it is 1, 1 is less than 1, conduction. Therefore, what is the choice? What is the choice of distance between x comma z? Mod of x minus z. Because distance between x comma z, if it is 1, 1 is less than 1. So there is no choice for 1. So what is the choice? Mod of x minus 1. Therefore, distance between x comma z is mod of x minus z. Similarly, distance between z comma y is mod of z comma y. So there are only two possibilities. So what I want to show? I want to show the distance between x comma y is less than or equals to distance between x comma z plus distance between z comma y. But what is mean by distance between x comma y? 1 comma mod of x minus y. I already told you this is always less than or equals to each piece, each member. But what is this? This is nothing but adding and subtracting z. Again, what is this? Therefore, this is nothing but this is less than or equals to mod of x minus z plus mod of z minus y. Therefore, what is this? Distance between x comma z. Using this step. Right? Therefore, distance between x comma z, x comma y less than or equals to distance between x comma z plus distance between z comma y. So triangle inequality holds in this case. So in both cases, we have done the triangle inequality. Hence, it is a metric. Is it clear the step? Is it clear the step? Put it in chart box.
Yes, sir. Yes.
So is it any? So does it mean that one plays any important role? No, right? If you take any k positive real number, this works. Right? If you take any k positive real number, right? If you take any k positive real number, minimum of 1 k comma mod of x minus y, you take k is any positive real number. This works, right? This works. So therefore, this is always a metric. Right? Same lines. Distance could be at most k and mod of x minus y. Therefore, this is 1, this is k, this is k. Therefore, this is k, this is k. So the same lines. So we can prove the same lines. Therefore, distance between x comma y is equals to minimum of k comma mod of x minus y is a metric whenever k positive. Right? So we can generalize this step. Suppose instead of taking usual metric, suppose you can take any set. D is a metric. What is my generalization? D is a metric. What is my generalization? So if you take D is a metric on a set X, suppose my delta of x comma y is equals to minimum of k comma d comma x comma y. This is always a metric by the same lines. What I said. This is always metric whenever k positive. Is it clear the step?
Yes, sir.
Minimum of k comma distance between x comma y whenever k is positive, always a metric. In fact, what is the property holds? This is bounded by k, this is bounded by d of x comma y. This is important. We'll use this step because this distance function is always bounded metric. This metric space is always bounded metric space because it is bounded by k. Right? Supremum make this. We'll talk about the distance of that supremum of that distance later. So therefore, in fact, it's a metric. Is it clear? It is bounded by k and it is bounded by t of x comma y. That is important. I'll use these steps later. Okay. So same example. Suppose I'm going to take distance between x comma y. If I replace this minimum by maximum, is it a metric or not? Put it in chart box. If I replace minimum by maximum, is it a metric? Put it in chart box. Voice is low. Okay. Now is it okay, Shivaji? Is it okay, Shivaji?
Yes, sir.
Voice?
Yes, sir.
Okay.
Thank you, sir.
Okay. So is it a metric? The answer. So non-negative, there is no problem because one is positive, non-negative. Therefore, there is no problem with non-negative. So what is my guess? Again, look at the guess. If you take x is equals to, suppose I can take x equals to 1, y equals to 1. What is my d of x comma d of x comma y? That is nothing but maximum of 1 comma mod of 1 minus 1. That is nothing but maximum of 1 comma 0. What is maximum of 1 comma 0? 1. Therefore, 1 not 0. So here x equals to 1, y equals to 1 means what? X should be equals to y, but the distance is not 0. X equals to y, but the distance is differ from 0. Therefore, it is not a metric. Is it clear? So minimum, if you take the minimum, it is a metric. But if you replace minimum by maximum, it is not a metric, right? That is important. Okay. Okay, example tone నేను generate చేస్తున్నానమ్మా. I generate the example with only one example. Right? So therefore, this is always a this is not a metric. right? Suppose right, suppose I'm going to take x is equals to r, right? Distance between x comma y equals to, suppose what you take actually 1 minus mod of x minus y by 1 plus mod of x minus y. Is it a metric? Is it a metric? The answer no, right? Because actually if I take x equals to 1, y equals to 1, what happens? Distance between x comma y is equals to 1 minus 1 divided by 1 plus 1 plus 1. That is nothing but what? 1 minus 0 by, this is 1 minus. So therefore 1 plus 0. That is nothing but 1. So 1 is different from 0. Here x equals to y, but distance between x comma y is non-zero. Therefore it is not a metric. Understand? So therefore it is not a metric. Now next argument, next example. If x is a set, any non-empty set, in fact cardinality minimum contains 2 elements. For sake of our convenience, I already told you when the cardinality is 1, we can have only one metric, right? So cardinality minimum 2. Okay. So therefore, suppose D1 is a metric. D1, D2 are 2 metrics on a set X. Question is that if D1 plus D2, is it a metric? Is it a metric? Right? Is it a metric? By the same lines, it are automatically metric, because you know that distance between x comma y plus distance between x comma y, you know that this is a metric means it is non-negative. It is non-negative. Sum of non-negative is always non-negative. Therefore, it satisfies first property. D1 plus D2 is non-negative for all x comma y belongs to X. So what is the second property? D1 plus D2 of x comma y is 0. You know that it is non-negative. Sum of non-negative is 0 if and only if each one of them is 0. Each one of them is 0. Because why? Because it is non-negative. Sum of non-negative is 0 if and only if each of them is 0. So you know that D1 is a metric. That means what? X equals to y. Therefore, second property also true. Even symmetry property also true. What is triangle inequality? What is triangle inequality? You start with 3 elements. But you know that D1 is a metric. Therefore, this is always less than or equals to D1 of x comma z plus D1 of z comma y. You know that D2 also metric. Therefore, this is always less than or equals to D of x comma z plus D2 of z comma y. So adding this and this. Therefore, it is always it satisfies the triangle inequality. D1 of x comma z plus D2 of x comma z plus D1 of z comma y plus D2 of z comma y. Therefore, is always satisfies triangle inequality. Therefore, D1 plus D2 satisfy first property, second property, third property, fourth property. Therefore, D1 plus D2 is always a metric. That means what? Sum of 2 metric is always a metric. What do you conclude? We can conclude that sum of 2 metrics is always a metric. Right? Next, what about the difference? If D1 is a metric, D2 is a metric, does it mean that D1, D2, D1 minus D2, is it a metric? Put it in chat box. Is difference of 2 metric, is it a metric? Does it mean the difference of 2 metrics, is it a metric? Is it a metric? The answer, no. The same idea. What you take? Suppose I'm going to take x equals to r. D1 of x comma y is equals to, suppose I'm going to take mod of x minus y. D2 of x comma y is equals to 2 into mod of x minus y. Both are metrics. I already told you k into mod of x minus y is always a metric. This is also a metric, usual metric. So both are metrics on R. So clearly D1, D2 are metrics on R. Question is that D1 minus D2, is it a metric? No, right? What do you mean by D1 minus D2? Mod of x minus y minus 2 into mod of x minus y. What is this? mod of x minus y. You know it is a negative function. Therefore, this d1 minus d2 is not a metric because it's a negative function. Mod is non-negative. Minus of this is always less than 0. Therefore, it is a negative function. Therefore, it is not a metric. So difference of two metrics need not be a metric on X. Right? So third one. What about the product? If D1 is a metric, D2 is a metric, does it mean that product metric? Does it mean that product metric? Put it in chat box. Does it mean that product metric? Yes. Mohammad Daku Pasha. Right. So it is no, right? Why? Because you know that I'm going to take again same strategy. So I'm considering x equals to r. D1 of x comma y is equals to mod of x minus y. This is dual metric, no doubt. Always metric. Similarly, D2 of x comma y also mod of x minus y. This is also metric because it's the same. Both are usual metrics. Therefore, both are metrics on R. What about the product? D1 D2 of x comma D1 D2 is nothing but mod of x minus y into mod of x minus y. That means what? Mod of x minus y whole square. Already told you this is not a metric. Mod of x minus y whole square is not a metric on R. Therefore, D1 D2 both are metrics, but whose product is not a metric? Understand? D1 D2 are metrics on same R, but whose product is not a metric on R. Is it clear? Put it in chart box. Is it clear, Amma?
D1 D2 సేమ్ మెట్రిక్స్ తీసుకున్నారు కదా సార్ ఇక్కడ సింగిల్ మెట్రిక్ అనుకోవచ్చు కదా సార్ D1 D2 సేమ్ మెట్రిక్స్ తీసుకున్నారు కదా సార్ ఇక్కడ
తీసుకున్నా రైట్
రెండు డిఫరెంట్ అనేది చూస్తున్నాం రెండు డిఫరెంట్ కాదు కదా
డిఫరెంట్ అని నేను ఇక్కడ చెప్పలేదు కదండి రెండు మెట్రిక్స్ ప్రొడక్ట్ మెట్రిక్ కావాల్సిన అవసరం లేదు నేను సేమ్ తీసుకోవాలని ఏమన్నా రూల్ ఉందా డిఫరెంట్ మెట్రిక్స్ అని కాదు నేను ఏమని చెప్పాను ప్రొడక్ట్ ఆఫ్ టూ మెట్రిక్స్ మే నాట్ బి మెట్రిక్ టూ మెట్రిక్స్ అంటే నేను ఏమైనా తీసుకోవచ్చు కదా సేమ్ తీసుకోవద్దని ఏమైనా ఉందా ఎస్ నో
ఓకే
సపోజ్ సేమ్ కాకుండా 2 తీసుకుంటా ఏమైనా ప్రాబ్లమా 2 తీసుకుంటా 2 into mod of x minus y whole square
ఓకే ఓకే
ఇది క్లియర్ సేమ్ తీసుకున్నా ప్రాబ్లం ఏం లేదు ఇన్ఫాక్ట్ కదా
ఓకే
సేమ్ తీసుకోవద్దని చెప్పలే కదా నేను d1 నాట్ ఈక్వల్స్ టు d2 అని మెన్షన్ చేశాను మెన్షన్ చేయలేదు కదా సో ప్రొడక్ట్ ఆఫ్ టూ మెట్రిక్స్ మే నాట్ బి మెట్రిక్ కదా
yes sir
okay so fourth one what about the difference d1 d2 if d1 is a metric d2 is a metric does it mean that d1 quotient of metric is it a metric put it in chart box
no sir
no good because it is not meaningful in fact it is not meaningful because d2 can be 0 d2 can be 0 therefore it is not a metric yes or no understand
Yes.
yes or no therefore d2 can be 0 therefore it is not a metric right so what you have seen that sum of two metric is always a metric difference of two metrics may not be metric product of metric may not be metric and division of two metrics is always is not a metric need not be metric in fact quotient is not meaningful because d2 can be 0 d2 can be 0 when you take x comma y equals to both are same d2 can be 0 understand when you take x comma x 0 therefore quotient may not be meaningful here therefore it is not a metric right suppose I'm going to take like this linear combination finite linear combination with non-negative constants suppose d1 is a metric d2 is a metric and a comma b are non-negative constants because why I'm taking non-negative constants already I told you d1 minus d2 is not a metric we have seen don't take negative constants so for avoiding that situation what I'm taking is that a should be non-negative b should be non-negative d1 d2 are metrics two metrics question is that is finite linear combination of d1 d2 means in fact the coefficients coming from the non-negative real numbers is it a metric
yes sir
Yes, sir.
is it a metric on same x the answer there are so many possibilities in fact a non-negative b non-negative means suppose I'm going to take a0 b0 what happens a0 b0 means ad1 plus bd2 is 0 function Constant function, therefore it is not a metric. Yes or no?
Sir, only for A greater than 0, B greater than 0 it is true.
Yeah, that means what? At least one of them is non-zero. At least one of them is non-zero, right? So if you take at least one of them, at least one of them, at least one of A comma B is non-zero. If you take at least one of them is non-zero, automatically A into D1, B into D2 is always metric. So these are very, very important properties, because I'm going to use these properties in every problem, because I don't want to check all the details. You know the standard metrics, you know the several metrics you have seen. So I don't want to prove each and every time this is a metric, this is a metric. I don't want to use it. So I'm going to use this step. So you always a metric, because D1 non-negative, D2 non-negative, therefore sum is non-negative, and the symmetry property holds and triangle inequality holds, therefore it is a metric. So finite linear combination of two metrics, finite linear combination of metrics with non-negative coefficients, at least one of the coefficient is non-zero, automatically metric. Understand? It can be extended to finite linear combination, not only D1, D2, D1, D2, D3, D4, D5, D6. Take finite metrics. Right?
Sir,
It is always a metric.
that is either A greater than 0, B greater than or equal to 0, or A
Yeah,
greater than or equal to 0.
ఏదైనా ఒక్కటి జీరో కాబట్టి చాలమ్మా. ఇక్కడ చూడండి, B0 తీసుకుంటే ఏమైనా ప్రాబ్లమా? B0 తీసుకుంటే ఏమొస్తుందమ్మా?
Yes, sir. Sir.
AD1. Already we have seen that A into D1 is always metric whenever it is positive. Right? At least ఒక్కటి జీరో కాబట్టి చాలు. నేను అదే అంటున్నా. At least. Is it clear?
Okay, sir.
Okay. So therefore, we have seen what you have seen actually. We have seen that algebra of two metrics, sum, difference, quotient, and products. Right? Suppose D1, D2 are two metrics on a same set X. D1 square plus D2 square whole power 1 by 2. Is it a metric? What you have seen that D1 square may not be metric. We have seen product of two metrics may not be metric. D2 square also may not be metric. But D1 square plus D2 square whole power 1 by 2. Is it a metric? Is it a metric? So suppose I can assume that this is nothing but D of x comma y is equals to D1 of x comma y whole square plus D2 of x comma y whole square whole power 1 by 2. Question is that is D is a metric on X? Is it clear? Whenever D1, D2 are metrics, is it a metric? So there is no problem with non-negative because it is non-negative. This is non-negative. Therefore, sum is non-negative. Whole power 1 by 2 also non-negative. Therefore, first condition holds. What is the second condition? Second condition also holds because actually D1 is a metric, D2 is a metric. Whenever x is equals to y, automatically that will imply that D1 of x comma y is 0, 0 square. D2 of x comma y, this is 0. Whole power 1 by 2, this is 0. Similarly, converse also true. So, and similarly, symmetry property also true. I don't want to prove it because the same details, right? So what about the triangle inequality? This is non-trivial. What is non-trivial? You start with three elements. X comma y belongs to x. D of x comma y. What is D of x comma y? D1 square of x comma y plus D2 square of x comma y. Whole power 1 by 2. So you know that D1 is a metric. Therefore, this is always less than or equals to D1 of x comma z plus D1 of z comma y. Whole, understand? Whole square. Similarly, D2 also metric. Therefore, D2 of x comma y less than or equals to D2 of x comma z plus D2 of z comma y. Whole square. Whole power 1 by 2. Right? So therefore, you know that actually I can assume that this is nothing but what actually I can assume this is R1, this is R2, this is R1 S1, this is R2 S2. So what is this? R1 plus S1 whole square plus R2 plus S2 whole square. Right? Whole power 1 by 2. But what is this? This can be rewritten as summation I equals to 1 to 2 Ri plus Si whole square. Whole power 1 by 2. Is it clear my sound? My voice?
Clear.
Okay. So therefore, so I'll tell you this property applying mean square square inequality. I'll tell you later. So applying mean square square inequality, this is always less than or equal to summation I equals to 1. I'll tell you in couple of minutes. So this is nothing but Ri whole square whole power 1 by 2. This is Ri whole square Si whole square whole power 1 by 2. This is exactly precisely same as saying that d of x comma z plus d of z comma y. I'll show you later by mean square square inequality. How to come this step? I'll show you by mean square square inequality. When you go through the function analysis, you know this inequality. Right? Therefore, this is always a metric. This is always a metric. This is always a. Is it clear? This step? Is it clear? So therefore, in general, sum is always a metric, difference may not be a metric. But the thing is that d1 square plus d2 square whole power 1 by 2, this is always a metric. This is very, very important. d1 square plus d2 square whole power 1 by 2 is always a metric. This is important. Understand? Did you understand this step? You need to simplify it, or else you need to simplify it. Or else you need to simplify it. So what you get it is nothing but what? What is R1? What is R1? R1 is nothing but what? d1 of x comma z whole square. What is R2? R2 is nothing but d2 of x comma z whole square whole power 1 by 2 plus what is s1 square? S1 square is nothing but d1 zy whole square d2 zy whole square whole power 1 by 2. But what is this? What is this? This is nothing but d of x comma z. What is this? Z comma. Therefore, this is always a metric. Therefore, it is always a metric. Right? Is it clear, all of you?
Yes, sir.
Okay. Next is
Yes, sir.
I can extend this idea to two dimensional. What we have seen that till now we have seen that on only R. Only R we have seen examples. Right? We have seen only on R, we have seen metrics on R, only R. So what I do is that I can extend this idea to n-dimensional vector spaces. In fact, n-dimensional, more dimensional vector spaces. So what I do is that let us start with another example. If I take x is equals to R square, if I take x is equals to R square, my function is, suppose I'm going to take x1 minus y1, whenever x is equals to x1 comma x2, y equals to y1 comma y2. Is it a metric? Understand? Till now we have seen only on R, right? We have seen a matrix on R. So what I do is that I can extend this idea to R square or R cube or R3 or n-dimensional vector spaces. So what I do is that let us start with simplest example. D of x comma y is equals to mod of x1 minus y1. Whenever x is equals to x1 comma x2, this is my order pair. This is my order pair. So question is that is it a metric? Is it a metric? Put it in chat box. Is it a metric? Right? Is it a metric? The answer for this?
Sir,
Is
d
it a
of
metric?
x is
Mod of
modulus
x,
of x minus y.
x1 minus y1, x1 minus y1. There is no meaning for mod of x minus y because x is an order pair, y is an order pair, whose difference is an order pair. There is no meaning for modulus of order pair. Understand? Don't take x minus y. When you take x is an order pair, y is an order pair, whose difference is an order pair, there is no meaning for modulus of order pair. So don't consider x minus y. This is nothing but x1, y1. Understand? x1 mod of x1 minus y1. Now it is meaningful because x1 is a real number, y1 is a real number, x1 minus y1 is a real number whose modulus is real number, therefore it is non-negative. So there is no problem with non-negative. So what is the second property? I can check. So what is the second property I'm going to check? So what is my expectation? Suppose I can take d of x comma y 0. That means what? What is my guess? Mod of x minus y equals 0. That means what? x1 is equals to 1, y1. x1 is equals to y1. What about x2 by 2? What about x2 by 2? You know x1 is equals to y1. What about x2 by 2? If I give x2 y2 are different, it can be fail, right? If I give x2 y2 are different, whose first two components are same, x1 equals to y1, so we can fail, right? This result fail, right? Suppose I can take x is equals to 1 comma 2, y is equals to 1 comma 3. What is the distance between x comma y? Is nothing but 1 minus 1. That is nothing but mod 0. That is nothing but 0. Does it mean that x equals to y? No, right? Because 2 not equals to 3. 2 not equals to 3. Therefore, x not equals to y. Distance is 0, okay, but the elements are different. Understand? Therefore, it is not a metric. Is it clear, Amma? Is it clear? Is it clear? Okay. So therefore, suppose I'm going to take this. Here x is equals to r square. D of x comma y is equals to mod of x1 minus 2y1. Is it a metric? Is it a metric? Again, same argument. So therefore, this is a real number. This is a real number. Modulus of real number is always non-negative. Therefore, this is non-negative because x1 real number, x2 real number, y1 real number, y2 real number. Mod of this real number is always non-negative. Therefore, first condition there is no problem. But what is the problem I can expect? I can take x to be what to do? What is your expectation? So I can take x is equals to what is this? X is equals to this. What is my y? What is my y? 2 comma 2 comma. Can you give me at least one element? So what is my guess? Actually, first of all, what is my guess? You know that what is my guess? Distance is 0. That means what? X1 minus 2y1. That is equals to 0. That means what? X1 is equals to 2y1, right? So I can take x1 is equals to 4, y1 is equals to 2. X1 is equals to 4, y1 equals to 2. That means what? I can take x1 to be 4, y1 to be 2. Rest of them are same. Rest of them are same. So what you expect? Therefore, d of x comma y is nothing but what? D of x comma y is nothing but what? Mod of 4 minus 2 into 2. That means what? 0. So distance is 0, but the elements are different. 4x not equals to y because 4 is different from 2. Is it clear? This is my guess. This is my guess. So therefore, distance is 0, but the elements are different. This is an R2, right? Suppose I can take d of x comma y is equals to mod of x minus y1 plus mod of x2 minus y2. Whenever x is equals to x1, x2, y is equals to y1, y2. Is it a metric? This is standard metric. You can check it. This is always by default. Already I told you sum of two metric is always a metric. So therefore, this is always a metric. We can check it, Amma, because we can take so many lengthy problems. Therefore, this is always non-negative. This is non-negative, and it satisfies symmetry property. Therefore, it is always a metric, right? So therefore, next one, d of x comma y is equals to. Suppose I'm going to take maximum of mod of x1 minus y1 minus y2. Is it a metric? It is also standard metric. You can easily check it, Amma. You can easily check it. So there are lengthy problems. So d of x comma y is equals to maximum of mod of x minus y1 modulus of x2 minus y2. This is always a metric whenever x is equals to this, y is equals to this. Question is that, is it a metric? Minimum of x1 minus y1 comma x2 minus y2. Is it a metric? Whenever x is equals to x1 y comma x2, y is equals to y1 y2. అర్థమైందమ్మా? ఈ రెండు స్టాండర్డ్ నేను ప్రూవ్ చేయట్లేను. ఈ రెండు స్టాండర్డ్, right? This is L1 metric. Simply one can call it as it is an L1 metric on R2. This is nothing but L infinity metric. There are standard metrics. For proving them, it takes time. Okay. So they are standard metric. They are metrics. Okay. Maximum of mod of x1 minus y1 modulus of maximum modulus of x2 minus y2 is always a metric. So question is that minimum of mod of x1 minus y1 comma mod of x2 minus y2, is it a metric? So non-negative there is no problem, right? This is non-negative, this is non-negative. Minimum of this is non-negative. Always it is meaningful. It is a real number because it's a compact set. right? So what about the problem? Second problem. Suppose minimum of this, suppose d of x comma y 0. What happens? Minimum of mod of x1 minus y1, mod of x2 minus y2 is 0. Minimum of 0 means, you know that minimum, when do you say that minimum 0? At least one of them is 0. Either this 0 or this 0. If at least one of them is 0, the minimum is 0. Why? Because both are non-negative, right? At least one of them is 0. Suppose I'm taking mod of x1 minus y1 is 0. That means what? x1 is equals to y1. What about x2, y2? So I can guess. So what I do? X1 is x is equals to 1 comma 2, y is equals to 1 comma 3. Because x1 is equals to y1, we don't know information about x2, y2. What I do? I can take x2, y2 be different. Keep x1, y1 are same. Therefore, we need to expect that whose distance is 0, but the points are different. Right? So mod of x1 minus y1. This is x1, this is y1. Therefore, modulus of 1 minus 1, comma, modulus of 2 minus 3. Therefore, what? Minimum of 0, comma 1. What is minimum? 0. So distance is 0, but the points are different. Is it clear? Is it clear? Put it in chat box. Okay, good. Okay, good. Okay, minimum may not be metric. So I can extend this idea to, in general, metric space. Means I can extend this idea to n-dimensional vector space. N-dimensional vector space, in fact, n is bigger than or equals to 1. So first example is, this is my L1 metric. This is nothing but what? Mod of x1 minus y1 plus x2 minus y2. What is this? This is L1 metric. Clearly metric. Already told you this is always a metric. So n-dimensional, right? N-dimensional means what? N-dimensional means what? It cannot stop for 2. That means what? Going on, mod of xn minus y1. That is simply same as saying that summation I equals to 1 to n, mod of xn xi minus ya, whenever x is equals to x1, x2, n tuple, y is equals to y1, y2, yn, which are in the R power n. Therefore, clearly it is a metric. This is a standard metric. I don't want to prove it. It's a metric. It is a metric on R power n. What is my D2? My D2 is nothing but usual distance between 2 points. Suppose you are given a point. You are given a point. What is the usual distance? Under root of x1 minus y1 whole square plus x2 minus y2 whole square plus x3 minus y3 whole square going on. That means what? Usual distance, Euclidean distance. So xi minus y whole square whole power 1 by 2. So this is nothing but what? Euclidean metric. Usual metric. Euclidean metric or visual metric on R power n. Right? They are metric. This is standard metric. So I don't want to prove it. So d2 of x comma y is nothing but what? Distance between 2 points. This is my point. This is my point. Suppose you take x1, y1, x1 comma x2. This is nothing but y1 comma y2. What is the usual distance? Under root of x1 minus y1 whole square plus x2 minus y2 whole square. Similarly, we can extend this idea to n dimensional. So d2 of x comma y is equals to distance between 2 points. This is a point. This is a point. Distance between 2 points. So this is always a metric. This is L2 metric. One can take it as a L2 metric. Right? What is this? D of x, d infinite of x comma y. This is a notation. This is nothing but maximum of modulus of xi minus ya. This is also standard metric. I already told you. This is a metric. This is also metric. Metric on R power n. These are the standard metrics. These are the standard metrics. These three are the very standard metrics. This is L1 metric. This is L2 metric. This is L infinity metric. Is it clear, Amma? Because by proving this, it takes time. So I don't want to prove it. Is it clear? Hello? Yes? Right? right? They are the matrix. Next example, suppose I'm going to take X is my set. Okay, yes, okay, good. Suppose X is nothing but set of all finite subsets of a non-empty set. Non-empty set. What is my X? Set of all finite subsets of X. The member in X is nothing but you take any member in X. What is the member in X? If and only P must be finite. What are the members in X? The members in X are nothing but finite sets. Suppose my function d of x a comma b is equals to cardinality of a minus b, or simply one can take union. Easily one can understand easily. We can take cardinality of a union b. Whenever a comma b are the elements in X. Is it a metric? Is it a metric? Is it a metric, comma? What is the cardinality? You know that is the cardinality meaningful? Yes, because A is a finite set, B is a finite set. Finite union of finite set is always finite set. Therefore, cardinality is finite set. Therefore, it is a finite real number. Therefore, distance is always non-negative. Why non-negative? Because if you take the cardinality of empty set is 0. Therefore, distance is here non-negative. So first condition there is no problem. Yes or no? Because A is finite, B is finite, whose union is finite. Finite set means it contains minimum 0 elements, 1 element, 2 elements, 3 elements. That means what? Cardinality is non-negative. Therefore, this is nothing but non-negative. So distance between 2 points. Yes. Yes. Is there any doubt?
Yes.
Okay. So what about the second property? What about the second property? If distance between a comma
union
b
equal to B union A, both are same.
Yeah. What about the second property? If distance is 0, that means what? Coordinate of A union B is 0. When do you say that coordinate of A union B is 0? That means A union B must be
Empty set.
empty set, right? A union B must be empty set. So A union B must be empty set. When do you say this? When do you say this?
A is empty set, B is empty set.
set. Okay, that means A equals to B. There is no problem, right? What about the reverse case? If you take A equals to B, what is the coordinate of A union B? What is mean by distance between A and B? Means coordinate of A union A. Coordinate of A union A is nothing but A union A is equals to A. So what is this? Is it 0? No, right? Coordinate of A need not be 0. So what is my guess? My guess is I can take any proper set. Suppose I can take 1, B equals to 1. Right? Right? Both are members of X for sake of our convenience. So therefore, what is the distance between A comma B? That means coordinate of A. What is the coordinate of A? Singleton 1, coordinate of A? 1. So 1 is non-zero. So distance between A comma B, what is A? A and B are both are same. Because A equals to singleton 1, B equals to singleton 1. Therefore, A equals to B, that doesn't mean that whose distance is 0. Therefore, it fails to satisfy the second property. Therefore, it is not a metric. Is it clear, Amma? This is my guess. If you take A equals to B, distance between A comma B is A union, coordinate of A union A. Coordinate of A is nothing but coordinate of A. Cardinality of A need not be 0. Cardinality of A is 0 if A equals to pi. This is positive, strictly positive, if A is not equals to pi. Yes or no? So this need not be 0. So I can take a non-empty set. A should be non-empty, B should be non-empty. If you take both sets are same, whose distance is different from 0, but the sets are same. Is it okay, Emma? Okay, good. So union is failed, right? Union is failed. But if you take the distance between A comma B is intersection. There is a member in X. Is it a comma B? Right? Is it a metric? So there is no problem with non-negative because cardinality of the any set always non-negative. Therefore, there is no problem with non-negative. First condition holds. What is the second condition? What is the second condition? Again, same strategy. If you take a equals to b, what is distance between a comma b? That means what? This is nothing but a comma a. That is nothing but cardinality of a intersection a is nothing but cardinality of a. Cardinality of a need not be 0. Understand? So what is my guess? You need to take a should be non-empty. Understand? If you take a equals to 1, b equals to 1, right? So that means what? A equals to b. What is the distance between a comma b? That is nothing but distance, cardinality of a. Cardinality of a is nothing but what? 1. 1 is different from 0. So a equals to b, but the distance is different from 0. Therefore, it is not a metric. So distance between a comma b, the coordinate of a intersection b is not a metric. Right? Suppose you can take distance between a comma b is equals to mod of coordinate of a minus b. Means set difference. Is it a metric? Is it a metric?
No.
No, good, very good. So what is your guess? What is your guess? So cardinality is non-negative, there is no problem. What is your guess?
A and B are non-empty sets.
Yeah, what is your guess? If the distance is 0, check the guess. If the distance is 0, that means what? Mod of a minus b is 0. That means cardinality of a minus b is 0. So cardinality of a minus b 0 means what? A minus b should be empty set. Understand? Cardinality of a minus b 0 means what? A minus b should be empty set. A minus b should be empty set means what? This a minus b can be written as a intersection b complement, isn't it? This is my a, this is my b, this is a intersection b. So a minus b is nothing but what? This. If you take the intersection on both sides, a intersection b, what you're getting? This union, sorry. Take the union with the intersection b, what happens? If you join the intersection, if you join the intersection, what you're
A
getting?
will come.
A will come, that's it. A will come. You join the intersection. So in left side must be A. What is right side? Phi union A intersection B? A intersection B. That means what? A intersection B equals to A means what? A should be small set. So what is A intersection B? A. So therefore A must be subset of B. So what is my guess? My guess is if you take A small set 1, you take B equals to 1, 2. Therefore A is always subset of B. There is no problem. Right? So what is the distance between A comma B? That means cardinality of set 1 minus set 1, 2. What is this? Cardinality of set 1 minus set 2 is nothing but what? Empty set.
Empty set.
Coordinate of empty is 0. Therefore, the sets are different. A not equals to B, but the whose distance is 0. Therefore, it is not a metric. Is it clear, Amma? Okay. Okay. Next is same example. If you take this A comma B is nothing but coordinate of A delta B. Is it a metric?
No.
So there is no problem with non-negative, right? Okay. There is no problem with symmetric because actually A delta B same as saying that B delta A. There is no problem with, so first of all, you need to check second property. What is second property? If the distance is 0, if the distance is 0, that means what? A delta B equals to 0. What do you mean by this? What do you mean by this? A delta should be empty. What do I mean by this? A minus B union B minus A is empty. What do I mean by this? Empty, sorry. Right? What do I mean by this? A minus B should be empty and B minus A should be empty. A minus B should be empty means what? Already I told you whenever A minus B is empty, A is always subset of B. B minus A is empty means what? Already I told you B subset A. So A subset B, B subset A. A equals to B. Is it clear?
Yes, sir.
What is the converse? If you take A equals to B, so what is the difference? Distance between A comma B. So coordinate of distance between A comma A. That means what? Distance between A comma A is nothing but A minus A union A minus A. That means what? Empty union empty. That means what? Empty. That is nothing but 0. Therefore, second property holds. What is the third property? Third property trivially holds. Right? What is the fourth property? Third property trivially holds. You know that. Because A delta B is same as saying that B delta A. So symmetry property holds. What about the triangle inequality? Start with 3 members. A comma B, B, C belongs to X. Right? I want to show that distance between A comma B less than or equals to distance between A comma C plus distance between C comma A. Right? I want to show this. So this is nothing but coordinate of A. This distance between A comma B is nothing but coordinate of A delta B. But A delta B same as saying that A minus B union B minus A. Right? Right? So therefore, this is nothing but A delta B is nothing but A minus B is nothing but A intersection B complement union B intersection A complement. But this is same as saying that A intersection B complement. I can rewrite it as intersection with universal set. That means I can take C union C complement. Right? Any set intersection with the universal set is always here. Right? So this is nothing but universal set can be written as C union C complement. Understand the idea? Is it clear the idea? This is nothing but this can be rewritten as like this. A intersection mu is nothing but A whenever mu is a universal set. Right? So mu can be replaced by C union C complement by set properties. Right? I can replace C mu by C union C complement. Is it clear? Is it clear the step? Same strategy. B intersection A complement union C union C complement. This intersection. Is it clear, Amma? Is it clear the step? This is the important step. Is it clear this step? Put it in chat box.
Yes, sir.
Okay.
Just we are added mu in universal set.
Okay, good. So therefore, this is nothing but this A intersection B complement. This that intersection is distributed over union. Therefore, what I do is that A intersection B intersection with C intersection union A intersection B complement intersection with C complement. Understand? A intersection B intersection is distributed over intersection. Therefore, A intersection B intersection C union A intersection B complement intersection with C union. Similarly, B intersection A complement intersection with C union B intersection A complement intersection with C complement. Because intersection is distributed over union as well as intersection is distributed over intersection. You know that. So therefore, this is true. So take this and this, this and this. First and last, last and this. So what I do is that this is always, coordinate of this. So what is this? This can be rewritten as, this is always less than or equal. You know that whenever A subset B, always coordinate of A less than or equals to coordinate of B. Yes or no? This is very standard, right? So whenever A subset B, B contains more elements, coordinate of B bigger than or equals to coordinate of A. Therefore, you know that I can apply that. So A intersection B complement, look at this, look at this. A intersection B complement, intersection with C complement, union, B intersection with A complement, intersection with C complement is nothing but one. So this can be rewritten as A intersection B. You know that in set theory, A intersection B is always subset of A as well as A intersection B subset of B. Therefore, A intersection B intersection C complement is subset of A intersection C complement. Union B intersection A complement intersection C complement is always subset of A complement intersection C complement. Right? No. C complement somewhere we are missing. This is C, right? This is C. B intersection A complement intersection C. right?
A intersection C complement.
Yeah, right. So therefore, this is always true. Therefore, coordinate of this is always less than or equals to coordinate of this, right? But what is this? What is this? This is nothing but A delta B, right? So coordinate of this is always less than or equals to coordinate of this. So coordinate of this is always less than or equals to coordinate of A intersection C, sir. A intersection C. So therefore, similarly, first and last, this is always less than or equals to coordinate of B intersection C. Therefore, this is coordinate of A intersection C plus coordinate of B intersection or C intersection B missed last name, right? So what is this actually? Distance between A comma C plus distance between A comma B. Therefore, it satisfies triangle inequality. Therefore, it is a metric, right? So set difference is only symmetric difference is only metric on the collection of a set of all finite subsets of a non-empty set. What happens if you take the infinite set? If you take infinite set, if you take the collection to be infinite, my collection to be infinite, is it a metric? The answer no, right? The answer no. Suppose my set is my collection. Suppose you take my collection is infinite collection of sets, collection of subsets of X. Means infinite subset, collection of infinite set, not infinite collection of infinite subsets of a non-empty sets, right? You take the same argument. What you do is that same A delta B. Is it a metric? No, because I can take A is infinite set. I can take A is infinite, B is finite, B is empty. A is infinite set. So what is the distance between A comma B? This is A delta pi. That means what? A minus pi union B minus pi minus A. That means what? A minus pi is nothing but A. This pi minus A is nothing but pi. That is nothing but A. That means what? Coordinate A is infinite because A is infinite. Understand? Therefore, you need to take the collection to be a collection of finite subsets of a non-empty set. Is it clear? Is it clear?
Yes, sir.
Okay, sir.
Yes. So I'm going to solve some problem based on this. Inka unnai, but okay, these are the questions which are asked in CSIR, GATE, and JLDL. Okay. So first question, let us look at this. Inka unnayamma, but time saripodu. Okay. అందుకే క్వశ్చన్స్ తీసుకున్నాను ప్రీవియస్ మోడల్స్. ఓకే
Yes, sir. Previous question discussed.
యా ఎందుకంటే టైం సరిపోదు మళ్ళీ నిన్న టైం వేస్ట్ అయిపోయింది.
Right.
Okay. So therefore, these are the questions which are asked in previous question paper, GATE, CSIR, like this. This is GATE 2021 recent paper. Okay. So first question. X is equals to my set is R. First question. My set X equals to R. First question. What is my D1? D1 of X comma Y is equals to under root of mod of X minus Y. D2 is nothing but mod of X minus Y whole square. Question is that first option, D1 is a metric, D2 is not a metric. Is it true actually? D1, what about D1? What about D1?
Sir.
Already told you.
Yes, sir.
Yes, it is a
You know that.
Metric.
Yeah, you know modulus of X minus Y is a metric. Square root of a metric is always a metric. Therefore, it is a metric. Question is that D2?
No, sir.
Not metric.
Not a metric.
No.
So what is the answer?
A.
D1 is a metric.
First one.
Yeah,
A.
first one. Yeah, good. Okay. Consider D1, D2 are metrics on a set X. Which of the following are true? Which of the following are true? These are in the GATE, recent question paper, GATE. D1, D2, product. D1, D2 of XY is equals to D1 of X, comma Y, D2 of X, comma Y. Is it a metric? Product.
No.
No.
Already
No.
I told you, you take mod of X
No.
minus Y, mod of X minus Y. Product is nothing but mod of X minus Y whole square. It is not a metric. So first option is not true. Question is that D3, maximum of D1, comma D2. Already I told you,
sir.
maximum of D1, comma D2 is always
Metric.
True.
Metric.
No.
Metric. Yeah,
Yes.
already told you standard. This is standard, right? Right? Is it okay?
Yes, sir.
Okay. Already
Yes,
I told you, right?
Sir, this is
D1.
L2 metric, sir. Standard.
It is not. It need not be L2. It need not be L2 metric, but it is a metric. Okay. I'll check. If you have a doubt, okay, I'll check. So therefore, d1 of x comma y, you know that it is non-negative because d1 is a metric. Similarly, d2 is not a metric, therefore it is non-negative. Therefore, non-negative means always non-negative. Therefore, total non-negative. So therefore, d must be non-negative. D3 is non-negative. So your function is non-negative. Therefore, it is okay. What is my second condition? d3 of x comma y is 0 if and only maximum of d1 comma d2 is 0. Maximum of d1 comma d2 is 0 means what? Each of the number is 0. So you know that d1 is a metric, d2 is a metric. Therefore, x equals to y. So second condition true. What about the third condition? d1, d2 are metrics. Therefore, third condition also true. So there is no problem with third condition. So what about the triangle inequality? That is important. You take 3 elements, right? So d1 of x comma y, you start with d of, I want to show that d3 of x comma y less than or equals to d3 of x comma z, d3 of z comma y. I want to show this. Is it true actually? Yes, the answer is. Because when you have a maximum, you start with d1 of x comma y. What is d1 of x comma y? This is always less than or equals to by triangle inequality d1 of x comma z plus d1 of z comma y by triangle inequality of the metric, because d1 is a metric now. So therefore, this d1 is always less than or equals to maximum of d1 comma x comma z comma d1 comma d2 of x comma z. Similarly, this also less than or equals to maximum of d1 of z comma y, d2 of z comma y. Right? So therefore, what is this actually? d3 of x comma z. What is this actually? d3 of z comma y. Therefore, d1 of x comma y. What do you observe? d1 of x comma y less than or equals to d3 of x comma z plus d3 of z comma y. Similarly, one can show that. Sorry, d1. Sorry, mute the mobile. d1. Okay, d1. Similarly, d2. If you take d2 of x comma y also less than or equals to d3 of x comma z plus d3 of z comma y. So this set, you consider this set, you take this set, this set is bounded above by this member. Yes or no? This is an upper bound for this set. Understand? This is always this d3 of x comma z plus d3 of z comma y is an upper bound for this set. Therefore, supremum of the set is nothing but least upper bound. Least upper bound is always less than or equals to this. Right? Is it clear? For this set, this right side part is upper bound. Supremum of the set is nothing but least upper bound. Therefore, this is less than or equals to this. But what is this? Supremum is nothing but actually what? Supremum is nothing but a maximum because it's a finite set. Finite set attains bounds, already told you. Therefore, maximum of this is always less than or equals to this. What is maximum? d3 of x comma y. Therefore, d3 of x comma y less than or equals to d3 of x comma z plus d3 of z comma y. Therefore, d3 satisfies triangle inequality. Hence, it is a metric. Is it clear, Amma? Is it clear?
Yes,
Hello?
sir. Yes.
అందుకే నేను ప్రూవ్ చేయనని అందుకే అంటున్నామా, ఎందుకంటే ఇవి లాంగ్ ప్రాబ్లమ్స్ కాబట్టి ప్రూవ్ చేయను, టైం వేస్ట్ అవుతుంది. ఓకే, సో దర్ ఫోర్ ఇట్ ఈస్ ఎ మెట్రిక్. సో మాక్సిమం ఆఫ్ d1 d2 is always a metric. Okay.
Okay, sir.
Right. Okay, look at the third one. d4 of x comma y is equals to minimum of third option. Look at the third option. So it is a metric. Okay, look at the third option. 5 comma 5 power 345 d1 plus d2. I already told you, look at the example which I already told, k d of x comma y. You know delta of x comma y. It is a metric space. It is a metric whenever k positive. You know that D1 is a metric you already given. D2 is a metric already given. Finite linear combination of metric is always a metric. Therefore, it is a metric. With the coefficients, at least one of them is positive. You know that pi power 345 is always positive. Here 1 also positive. Therefore, finite linear combination of metric is always a metric whenever the coefficients are positive. In fact, at least one of them is non-zero. Therefore, this is a metric. So whenever this is a metric, here k is positive. What is my k? K is positive. Therefore, minimum of this, whenever D is a metric, k is positive, is always a metric. Is it clear, Amma? Because this is a metric. D1 metric, D2 metric, finite linear combination of metric is always a metric, provided the constants should be non-negative, at least one of them is non-zero. Therefore, this piece is a metric, and k is here pi is positive. Therefore, minimum of something is always a metric. Is it clear?
Yes, sir.
We don't want to prove it. Time waste. అందుకే అది use చేయాలి. Basic arguments use చేయాలి. So therefore, it is a metric. So what are the options? B and C are the options. Okay. Next, third one. This is GATE 221. ఇవన్నీ GATE questions, CSIR questions అమ్మా. So therefore, first one. What is D1? What is my set actually? X is equals to 0, 1. Right? So therefore, is it a metric? Is it a metric? Yes, already I told you. D1 of x comma y is nothing but what? D1 of x comma y is nothing but what? Log of x by y. I already told you this is nothing but log x minus log y. Yesterday I told you this is a metric. Is it clear? This is non-negative. It is an increasing function, monotone increasing function. Whenever you have a monotone increasing function, always metric. Already told you. Whenever d of x comma y, f of x minus f of y, whenever f is increasing function, always metric. So log x is always an increasing function. So log x is increasing function. So therefore, it is a metric. Is it clear, Amma? Yesterday I told you. It is
Yes,
an
sir.
increasing function. So therefore, it is a metric. Next. So this is a standard question. Again, this is a standard question. What is standard actually? So what is the question actually here?
Discrete metric.
So what is a metric actually here? So what is a metric? So d of x comma y is equals to mod x mod y if x not equals to y, 0 if x equals to y. I think this is a metric, right? Yes or no? So this is a metric, right? So question is that, is it a metric? Question is that, is it a metric? Yeah, question is that, is it a metric?
Yes, sir.
So first you need to check whether it is non-negative or not. Yes, it is non-negative because mod is non-negative, this is non-negative, sum is non-negative, here 0 also non-negative, therefore total is non-negative. Therefore, there is no problem with non-negative. So what is the second property? If xy equals to 0, already we know that distance is 0. So second property also, one condition is hold. So whenever x is equals to y, whose distance is 0. Therefore, this second property, first implication is true. What about the second property? Converse. If the distance is 0, if the distance is 0, does it mean that x equals to y? Does it mean that x equals to y? The answer yes, because if x not equals to y, right? What is my distance? Mod x, mod y. You know that x not equals to y means both cannot be 0. Both cannot be 0. Both cannot be 0. Understand? If both is 0, if x equals, therefore x equals to y. Therefore, both cannot be 0 means what? At least one of them is positive. At least one of them is positive because mod is. So at least one of them positive means what? Total positive. Therefore, distance is positive. But it's obviously conduction. Why? Because we assume that distance is 0. So conduction. Therefore, why are getting conduction? If x not equals to y, are getting conduction. Therefore, x must equals to y. Therefore, distance between x and y is 0 if only if x equals to y. Right? Symmetric property also true. Why? Because
Sir, please once again explain, sir. When d of xy equal to 0 implies x equal to y.
yeah. క్వశ్చన్స్ వస్తే అడగండి అమ్మా, ఎందుకంటే నేను ఫాస్ట్గా వెళ్ళిపోతున్నాను. ఓకే, ఇఫ్ d of x, y 0, what about x equals to y? Is it x equals to y? The answer is yes. Why? Because if x not equals to y, what happens first of all? If x not equals to y, the distance between x and y is nothing but mod x mod y. If x not equals to y, does it mean that x equals to 0, y equals 0? No, because if x equals 0, y equals 0, x equals to y, right? So therefore, at least one of them is non-zero. At least one of them is non-zero because you're assuming that x not equals to y. Understand? So at least one of them is non-zero. That means what? At least one of them is positive. Therefore, total positive. So this is absolutely conduction. Why? Because your distance is 0 now. Your distance, you're assuming that distance is 0. Why, what you're getting? Distance is positive. So conduction. Why you're getting conduction? You're assuming that x not equals to y. Therefore, x equals to y. Is it clear, sir?
Okay, sir. Thank you, sir.
Okay. So what is third property? Third property is redundant. If x equals to y, distance is 0. That means distance between y comma x, because x equals to y means y equals to x, automatically true. X not equals to y means distance between x comma y equals to mod of x plus mod of y. This is same as saying that mod x plus mod y plus mod x is nothing but distance between y comma x. Therefore, symmetric property holds. So what happened for the triangle inequality? Right? Is it true actually? The same argument yesterday I told you. If x equals to y, nothing to prove. If x equals to y, what happens? If x equals to y, what happens? Distance between x comma y is 0. 0 is always less than or equals to distance between x comma z plus distance between z comma y. Why? Because this right side part is non-negative. Understand? Because distance, we have shown that distance is non-negative. We have shown that this non-negative. Therefore, if x equals to y, nothing to prove. So what is your case? You need to show. You need to show the result for the case whenever x is not equals to 0. Whenever x equals to not equals to 0, already I told you there are 4 cases. Either z is equals to x, z not equals to y. Z is equals to z not equals to x, z is equals to y. Z not equals to x, z not equals to y. Z is equals to x, z is equals to y. Already I told you z not equals to x. This is not true. Why? Because if z is equals to x, z is equals to y, what you're getting? X equals to y.
equal to y.
Is it true actually? No. Therefore, this case is not possible. So what are the case we are left with? We are left with only 3 cases. Suppose z is equals to x, z not equals to y. What happens? I want to show the triangle inequality. I want to show that this is bigger than or equals to distance between x comma z. So what is whenever z is equals to x, what is mean by distance between x comma z? 0. Right? So this is nothing but whenever z not equals to y, what is mean by distance between z comma y? Whenever z not equals to y, what do you mean by distance between z comma y?
Mod z
Mod
plus
z
mod y.
mod y, right? Right? So therefore, but what is z? Z is nothing but x, right? But this is exactly same as saying the distance between x comma y, because x not equals to y now. Whenever z is equals to x, x not equals to y. Therefore, distance between x comma z is equals to distance between z comma y equals to distance between x comma z. In this case, there is no problem because equality is no problem. Equality is no problem. Is it bigger? Is it less than? No, right? Equality is no problem. Equal means greater than equals to. I can write it as a greater than equals to. Nothing wrong. Therefore, inequality hold in this case. If you take this case, distance between x comma z plus distance between z comma y, z not equals to x. What is my case? Z not equals to x means mod z mod x. What is z is equals to y? 0. Therefore, mod x. What is my z? Z is nothing but y. You know that z not equals to x means, you know that z is equals to y means what? Y. Therefore, y not equals to x. Whenever y not equals to x, what is this? Distance between y comma x. Right? So there is no problem. So equality holds. Equality holds and safe anante. There is no problem. So therefore, what is the third one? X not z not equals to x, z not equals to y. So distance between x comma z, distance between z comma y. What is this? X not equals to z means mod x mod z. What is this? Mod z mod y. Yes or no? Therefore, this can be rewritten as mod x plus mod y. Yes or no? Because this is a non-negative constant. Bigger quantity. Understand? Mod x plus mod y is always less than or equals to mod x plus mod y plus mod z plus mod z, because this is a non-negative constant. Because this is a non-negative constant. So this is always bigger than or equals to this piece. Yes or no? Because this quantity is bigger. These are non-negative constants. This inside one are non-negative constants. Yesterday I told you, whenever A is less than or equals to B, C non-negative. This A less than or equals to B is always less than or equals to B plus C. Whenever C is non-negative. Is it clear? Here mod Z is non-negative, mod Z is non-negative, there is no problem. So this is always bigger than or equals to this. But this is
Yes.
always less than or equals to mod of x minus y, another version of triangle inequality. Yes or no? Of course, this can be rewritten directly. The problem is over, right? So Z not equals to mod x mod y. What is this?
Distance between x comma y.
Right? So therefore, in all cases, the triangle inequality holds. Therefore, it is a metric. Therefore, it is a metric. Is there any doubt? Right?
No.
Okay. So therefore, this is also a metric. So which of the option is true? D. B, C, D. So what are the true?
D.
D.
Option D.
Option D. Right? Next. Fourth one. So you know that distance between x comma p. So did I tell you this concept? P bigger than 1?
No, sir.
No, right? Okay, I come to that question later.
Okay.
I'll finish this
Okay. Sir.
because it's a long concept.
Okay, sir.
Okay. Next, use this. You know, D1 is nothing but what I already told you. This is L1 metric on R power n. This is L2 metric, Euclidean metric on R power n. Right? D1 metric, D2 metric. There is no problem. Is it a metric? D, is it a metric? Is it a metric? First option.
Metric.
Yes.
Yes,
Of
because
course.
already
Yes.
told you D1 metric. What is my D? D is nothing but T1 plus D2 divided by 1 plus D1 plus D2. 1 plus D1 plus D2.
The distance.
Already I told you D1 plus D1 metric, D2 metric means sum of metric is always metric. Therefore, this is a metric. You know that this is also metric. I already told you this is nothing but 1 plus D into delta D. So D by 1 plus D is always a metric. Already told you. Yes or no? Yes or no? Where delta is nothing but what? D1 plus D2.
Yes, sir. Yes.
So sum of metric is again a metric. So this is in the form of delta by 1 plus delta, where delta is nothing but D1 plus D2. You know that sum of metric is always a metric. That means what? Delta is a metric. Whenever delta is a metric, delta by 1 plus delta is always a metric. So therefore, this is a metric. Right? Now, question is that, is it a metric? Difference of metric. Is it a metric? For this,
No, sir.
No, sir. No.
give counter. Give counter. See, these metrics are different now. This is L1 metric, this is L2 metric. How to give counter? Say no means you need to give counter. Yes or no? Which property fails? See, mod xy ఇక్కడ వర్కౌట్ కాదమ్మా, ఎందుకంటే what is the metric? L1 metric, na? Different metric. So what is my counter is that I can take, see I can take x is equals to,
Sir, voice low in, sir.
voice is low now. Okay, is it okay now?
Yeah,
Is it
now
okay, sir?
now okay.
Okay. Suppose I can take, what is my space here? R power n. So take an element 1 0 0 0 0 0 R power n. It is an element of R power n. Similarly, I can take y equals to 0 1 0 0 0 0 0. What is mean by d1 of x comma y? What is mean by d1 of x comma y? Summation 1 minus 0. That means 1 minus 0. Understand? Summation, what is this? Summation xi yi. Summation modulus of xi yi. That means what? 1 modulus of 1 minus 0 plus modulus of 0 minus 1 plus
0 minus
modulus of 0 minus 0 going on modulus of 0 minus 0. What is this? Modulus of 1 minus 0 is nothing but 1. This is nothing but 1. This is 2. Is it okay? D1 is nothing but 2. What is D2? D2 is nothing but this minus this. D2 is nothing but Euclidean distance summa under root of x1 minus y1 whole square plus x2 minus y2 whole square plus x3 minus y3 whole square going on xn minus yn whole square whole power 1 by 2. What is the distance between two numbers? Euclidean distance. 1 minus 0 whole square plus 0 minus 1 whole square going on 0 minus 0 whole square whole power 1 by 2. So 1 minus whole square is 1. 1 plus 1 whole power 1 by 2. Yes or no? So what's the problem? There is no problem there. So we are not getting any contradiction, right? We are not getting any contradiction, right? So what is the problem here? Whole power 1 by 2 is there, not? Yeah. So it doesn't work, right? It doesn't work, right? Right? Because it is nothing but what actually? Root 2. ఒక పని చేయండి అమ్మా, ఇక్కడ ప్రాబ్లం ఏమొస్తుంది, 2 మైనస్ రూట్ ఈస్ పాజిటివ్ వస్తుంది కదా కదా. సో కాబట్టి దీన్ని ఎక్స్టెండ్ చేయండి. దీన్ని ఏం చేస్తారంటే సమ్ సో 2 ఇవ్వండి అమ్మా, 2 రైట్. ఇక్కడ ఏమొస్తుంది మీకు 3 వస్తుంది, ఇక్కడ 2 వస్తుంది, ఇక్కడ 3 వస్తుంది. ఓకే రైట్. ఇక్కడ ఏమొస్తుంది 1, ఇక్కడ ఏమొస్తుంది అమ్మా, ఇక్కడ ఏమొస్తుంది 1, ఇక్కడ ఏమొస్తుంది అమ్మా
square root 5. 1 minus
so 4 plus 1 root 5. So అప్పుడు కూడా ప్రాబ్లం వస్తుందమ్మా. So therefore how to crack this problem? So I can take what is idea? What is idea? Anybody give idea? So therefore x is equals to, so I want this to be very small. I want this to be very small, this to be very big. So okay, how can you give that? So how can you counter? So therefore this to be very small, this to be very big. So different display problems ఉంది కదా. So right. So what is the guess? ఒక పని చేయొచ్చు కదా, ఏంటంటే సిమెట్రిక్ ప్రాపర్టీ ఫెయిల్ అయిపోతుంది చూడండి. ఎందుకంటే ఫస్ట్ చేస్తే ఏమొస్తుందమ్మా, 1 1 తీసుకుంటే ఏమొస్తుంది,
ఇన్ కేస్ ఫ్రాక్షన్ లో తీసుకొని ట్రై చేసినట్టు ఒకసారి వస్తుండేమో సార్.
ఇప్పుడు సిమెట్రిక్ ప్రాపర్టీ చూడండి అమ్మా ఒకసారి, జస్ట్ చెక్ సిమెట్రిక్ ప్రాపర్టీ. సిమెట్రిక్ ప్రాపర్టీ x ఈక్వల్స్ టు 1. ఇదే ప్రాబ్లం తీసుకోండి, ఇక్కడ 1 తీసుకోండి, నో ప్రాబ్లం. ఇక్కడ 1 తీసుకోండి. సిమెట్రిక్ ప్రాపర్టీ తీసుకుంటే ఏమొస్తుంది మీకు, సిమెట్రిక్ ప్రాపర్టీ తీసుకుంటే ఏమొస్తుంది, ఇక్కడ 2 వస్తుంది కదా, ఇది 1 అనుకుంటే ఇదేమైతే రూట్ 2 అవుతుంది కదా. సో దర్ఫోర్ d1 మైనస్ d2 ఏమవుతుంది, 2 మైనస్ రూట్ 2 వస్తుంది. d2 మైనస్ d2 d1 ఏమైంది, నో. సో సేమ్ వస్తుంది కదా ఫ్రాక్షన్స్ కదా, సేమ్ వస్తుంది d2 మైనస్ d1. సో సో సేమ్ వస్తుందమ్మా, సేమ్ వస్తుంది రైట్. ఓకే, ఈ ఆప్షన్ ఒకటి వదిలిపెట్టండి అమ్మా, చూద్దాం. ఓకే, సో d1 ప్లస్ d2, d1 ప్లస్ d2
metric.
is a metric. No problem. No problem, right? d1 is a metric. Already I told you, e power pi, e power pi, e power minus pi. Finite linear combination of metric is always a metric. Therefore this is a metric, this is a metric, this is a metric, this is a metric. So how to guess this? So 754 అయిందా? ఓకే,
నెక్స్ట్ క్లాస్ లో చూద్దాం సార్. అది నెక్స్ట్ వెళ్ళిపోండి. వాళ్ళ అసైన్మెంట్ అనుకుంటారు, హోంవర్క్ ట్రై చేస్తాం.
ఓకే ఓకే ఓకే. సో ఈ ప్రాబ్లం చూడండి అమ్మా, ఈ ప్రాబ్లం చూడండి, ఈ ప్రాబ్లం కూడా సేమ్ ఉంటుంది. దర్ఫోర్ ఇంతకుముందు మీకు చెప్పాను. సో ఇది కూడా వేరే ప్రాబ్లం, రేపు డిస్కస్ చేద్దాంలేండి. ఓకే
Okay, sir.
ఇస్ దేర్ ఎనీ డౌట్?
No, sir.
Okay, I hope you understand all the details, but you need to check this. You need to give two elements which are whose distance is 0 but x not equals to 1. x not equals to y. Right? Is there any doubt, Amma? Okay. ఈ క్వశ్చన్స్ రేపు సాల్వ్ చేద్దాం ఎందుకంటే ఇవి వేరే క్వశ్చన్స్. ఓకే
7 more good ఉంటారు.
హలో
సార్ 7th వన్ అంటే చూపించండి సార్. 7th వన్
7th వన్. ఓకే
స్క్రోల్ చేయండి, వాళ్ళు చూస్తారు. నెక్స్ట్ రేపు ఏమైనా ట్రై చేసుకోండి.
2019 ఈ క్వశ్చన్ సాల్వ్ చేయొచ్చు బట్ టైం లేదని ఆగుతున్నాం.
ఓకే నెక్స్ట్ చూద్దాం సార్. జస్ట్ స్క్రోల్ చేసుకుంటాం మిగతా.
Sir, if you don't mind, can you send in group? We will solve.
ఓకే
Yes.
ఓకే
If possible, we will work on it. Otherwise, we will discuss it.
ఓకే ఓకే I'll send this question paper in a group. We can discuss in a group. Okay.
Okay, sir. Thank you.
మీరు ప్రయత్నం చేయండి, తర్వాత నెక్స్ట్ డిస్కస్ చేయండి.
ఓకే
రైట్.
ఇవన్నీ యాక్చువల్లీ 15 క్వశ్చన్స్ ఇంత ముందు గేట్ CSIR లో వచ్చినాయమ్మా.